Hello everyone, in today's video we'll be discussing on programming the 8051 to transfer data serially and to receive data serially using C. Here are the topics that we'll be discussing in today's video. Firstly, we'll be discussing on the introduction, followed by setting up serial communication on the 8051, steps for transmitting data serially from the 8051, steps for receiving data serially on the 8051, implementing interrupts for serial communication, error handling in serial communication, practical applications of serial communication on the 8051, and finally the conclusion. Introduction. The 8051 microcontroller is widely favored in embedded systems for its versatility and ease of programming. Serial communication is crucial for enabling data transfer between the 8051 microcontroller and external devices. Implementing serial communication on the 8051 microcontroller is essential for its integration with other hardware. The use of C language streamlines the process of programming serial communication on the 8051 microcontroller. Programming serial communication in C on the 8051 enhances development efficiency and system functionality. Setting up serial communication on the 8051. Configure the UART registers on the 8051 microcontroller to enable serial communication. Set the baud rate to ensure proper synchronization between the transmitter and receiver. Initialize the serial communication settings, including data frame format and parity. Adjust the serial control, that is SCON register, to specify the desired communication mode. Use the timer 1 in mode 2 to establish the required baud rate. Steps for transmitting data serially from the 8051. Timer 1 is configured in mode 2 by setting the TMOD register to 20H. The baud rate for serial data transfer is determined using values from table 0 to 10 to 4 with an XTAL frequency of 11.0592 MHz. Setting the SCON register to 50H configures serial mode 1, which includes 8 data bits framed by start and stop bits. Timer 1 is started by setting the TR1 bit to 1 and instruction clear T1, that is CLR T1, is used to clear the T1 flag. Data to be sent serially is written into the SBUF register. The T1 flag bit is monitored using the JNB T1 command. The procedure ensures proper setup and transmission of serial data using timer 1 and the SCON register configurations. Steps for receiving data serially on the 8051. Timer 1 is configured in mode 2 with the value 20H in the TMOD register to set the baud rate. To establish the baud rate, the TH1 register is loaded with a specific value from table 10 to 4 based on an XTAL frequency of 11.0592 MHz. The SCON register is set to 50H, enabling serial mode 1, which frames 8-bit data with start and stop bits and activates receive enable. Timer 1 is started by setting the TR1 bit to 1. The clear R1 instruction clears the R1 flag. The JNB R1 command monitors the R1 flag to check if a full character has been received. When the R1 flag is set, the received byte is in the SBUF and is then moved to a secure area before repeating the process for the next character. Implementing interrupts for serial communication. Configure interrupt handlers to manage incoming data asynchronously, optimizing system responsiveness. Implement interrupt service routines for both receiving and transmitting data, enhancing serial communication efficiency, utilize interrupts to streamline data processing, improving overall system performance and resource utilization by integrating interrupt-driven mechanisms. The system achieves seamless data handling, enhancing reliability and responsiveness. Error handling in serial communication. Implementing parity bits enhances data integrity by adding redundancy to each transmitted byte, enabling error detection and correction. To maintain reliable communication, handling error conditions like buffer overflow or framing errors is crucial, as these issues can corrupt data and disrupt the transmission process. Utilizing error flags and status registers enables real-time monitoring and troubleshooting of serial communication issues, facilitating swift identification and resolution of errors. Error checking mechanisms such as parity bits serve as an essential component for ensuring data integrity, providing a reliable means to detect and correct errors that may occur during transmission. Practical applications of serial communication on the 8051. Utilize serial communication to interface sensors, displays, and peripherals with the 8051 microcontroller, enhancing its functionality. Design robust communication protocols, facilitating seamless data exchange between multiple 8051 microcontrollers, enabling collaborative tasks. Leverage the serial communication capabilities of the 8051 to develop IoT applications, enabling remote monitoring and control of connected devices. Implement efficient data transmission schemes over serial communication channels to facilitate real-time interaction and data processing in IoT environments. Conclusion. Utilizing C language for serial communication program or the 8051 microcontroller broadens the scope of embedded systems development. Proficiency in serial communication method with the 8051 microcontroller elevates the effectiveness and efficiency of projects based on microcontrollers. Consistent exploration and practice with serial communication can foster creative solutions and progress in embedded systems development. Mastery of serial communication techniques on the 8051 microcontroller empowers developers to innovate and push the boundaries of embedded systems technology. Thank you.